see the list. Well, are you recording yet?
Yes, we are.
Okay.
We're set to go.
Well, welcome to the September 8th, 2020 session of Tangerine SDR on Zoom with our HamSci participants all here. So first on the list, let's see, I've been basically busy with getting ready for the DCC with George and Scotty, and we're working through the how to make it work. We'll see if we can do it as smoothly as Nathaniel did his meeting, so we hope so. And so that's about it for me. Next on the list, I have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Everything's going fine here. I'm just trying to keep up with classes, and I submitted my DCC presentation, and I'm looking forward to it. W2NAF, back to net.
Fine business. Next on the list, we have Dave Witten, KD0EAG. Go ahead, Dave.
Hello, everyone. I have not had much time to do anything this last week. Kind of put together that presentation. Not real thrilled with it, but it's there. And I had to go to Chicago for several days and finally got back, and here I am now. So otherwise, I've been playing with a little Internet of Things module, one of the zillions of kinds, but not had really any time to play with anything. So that's that for now. Back to you.
Fine business. And next on the list, we have Dev. Go ahead, Dev.
Hello, everyone. Good evening. So it's we have started the week today. I have assembled a new N200 device installed in a new computer, in another computer, which would be taken to Nathaniel's house, and we'll try to collect data at two places. And we expect Nathaniel's house to be to have more radio quiet environment. It will have less noise. So we're looking forward to it. Thank you.
Fine business. And so next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to you and good evening to the net. Been pretty busy here. Prepared my speech and video and everything else for DCC. And in the meantime, I've also gotten Whisper Decoder working on the Tangerine localhost prototype. Now, as you may recall, I'm using a really crummy way of decimating, so I'm only getting the top one or two most powerful signals in the band, and I have an idea on how I could correct that. I'm going to run this by, and maybe Tom McDermott could listen to my idea and see if my idea on how to correct this is correct. The Flex Radio puts out 48,000 samples per second, and the Whisper Decoder looks for 375 samples per second. And so right now, the poor man's decimation is to just take every 128th sample. However, that folds back in noise. So I'm thinking what I really need to do in the simulator is I need to collect 48,000 samples, which is 1 second's worth, and then run an FFT on that, and then clip out the 375 bins in the middle that correspond to the piece of spectrum I want, and then do a reverse FFT to put it back in the time domain and then push those 375 samples into the decoder. And I think that that might filter out all the garbage that is outside that 375 hertz passband. Does that sound like the right approach?
Yes. Based in the time domain, you would low pass filter the 1/2 of the output sample rate and then keep 1 out of n samples. In the frequency domain, you can do it with an FFT, but I think that you'll get some artifacts unless you overlap and add samples between successive FFTs. Those artifacts may not be significant, and you might be able to just use the FFT. Now, in the FFT, if you put in real samples, then the output of the FFT is going to be a mirror image, symmetrical, about 0. If you put in complex samples, then you'll get negative and positive frequencies about the 0 point of the FFT.
Yeah, I was planning on doing this with complex samples since I do have complex data to work with. But anyway, the upshot of it is, on the Tangerine localhost prototype, decoding is working, but I'm only getting 1 or 2. I don't even always get a decode, but if there's some really strong signals out there, I'll get a decode. But that, I expected that, and I'm going to play with it because I'm going to try and do this filtering using doing the FFT and converting it to the frequency domain and clipping out what I want, converting back to time domain, because I think the Carnegie Mellon people would like to use the simulator that I have written. This is an idea that Nathaniel had for adapting the grape to interoperate with the Tangerine localhost. So anyway, making progress on that, slowly but surely. So back to net.
Okay, you may want to be careful not to just arbitrarily zero the samples outside the window and keep the samples inside the window, because you'll get a lot of ringing in the filter. So you have to kind of slowly ramp down the samples at the edge of the frequency passband.
Ooh.
Bill, another thing you could do is you could do a CIC filter in software, which is not that difficult. It does give you a lot of a sync type response way out away from the cutoff frequency. But if you're just looking for maybe 30 dB of reduction, really not very robust, that might be something you could do. And then you could do what Tom says, is just filter it first and then throw away the samples. And that way you don't get the aliasing because you filtered it.
Yeah,
The advantage of doing it in the frequency domain is because you're filtering quite a bit. The FFT is a much more efficient filter than most filters. What Scotty mentions, the CIC, is a fairly efficient comb filter, but then you have to follow that on top with a second filter to kind of take down some of the high order stuff. There's probably a lot of tricks you can get away with because you probably don't care about super high quality.
Well, even when you do it in the FFT, if you don't do a brick wall filter, you can still create a decent filter without a lot of the ringing, right?
Yeah, once you're in the FFT or frequency domain, if you roll off the samples about the Nyquist point gently, like with a raised cosine roll off, the FFT is much more efficient computationally for that kind of a filter than trying to filter in the time domain.
But really, what it really basically just comes down to applying some sort of correct low pass filter before doing the downsampling.
And the idea is, if you don't really care what the ultimate rejection of the low pass filter is, you can do a lot of cheap and dirty ones that maybe only give you 30 dB and in the time domain. But if you want something that's much more robust, then it's going to be harder in the time domain, like Tom says.
well, it's very feasible to do this in the frequency domain, because for me to take 48,000 samples and run an FFT on it, that happens in the blink of an eye. And then I take and clip out the bins that I want and do a reverse FFT. To do it, that at 375 samples per second is no problem at all on the Odroid, because you only have to do it once a second and then you're off to the races. So anyway, I'll keep you informed on what my results are on that. Okay, back to Ned.
Okay. Well, fine. Next on the list, we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, thanks, Dave, and good afternoon, evening to everyone on the net. About the same as Bill. I got my presentation, my slides done, and my recording done for DCC, and have spent some more time on the data engine. I'm just about finished with it. I'm in the kind of in the checking mode, just making sure everything is connected right. And then I'm beating my head against the wall trying to get the RAM working. And because the RAM has got to work with the pinout that we pick on the board before we go and build a board. So I'm basically building an FPGA image with the pins assigned and instantiating the RAM IP. And basically, I'm just going to take the A to D inputs and I'm just going to write them to RAM. That'll be the test case. It won't really do anything useful, but it will show that I can acquire data from the A to Ds and I can write the data to RAM, and I can meet all the timing. So the FPGA software will do all the analysis and say, yep, you either met timing or you didn't meet timing. So give us a kind of a feel good for when we get real hardware. Because if you make a mistake, you can fix it now, but you don't fix it now, you'll be in trouble when you commit it to hardware. And then whoever put that SDR on the Tangerine list, it's his fault. I had to go buy one of them. Those RX888, I mean, I have a weakness for these things. So it's, in fact, if I could, I'll wait to share my screen until we go to the general one, but I'll show you what it's like. It's they're on eBay and they're cheap and they're full 32 megs of bandwidth below 32 megahertz. So I don't really believe what they say in their ads there, but we'll try it out and see if it really works. And the interesting thing is, it appears that they just take the 32 megs of sampled data and they just spew it out the USB 3 port. There's no FPGA on board, so the only processing they can do is with the CPU that does the USB 3 interface. Well, if that's the case, one of the first things we could do with the data engine is emulate them, because we have a USB 3 port. So we could just spew the data out USB 3 and we could look just like this RX888 board. And they've got EXTIOs and everything already set up to talk to it. So it might be a really easy way to get on HDSDR in like 5 minutes. So anyway, that's what's been going on here. Back to you, Dave.
Well, fine business. And let's see, next on the list, we have Dan, N4XWE.
Thank you, Dave, and hello, everyone. Can you hear me okay?
Yes.
All right, thanks. Didn't do much this last week. Let's see, actually did go back to work for 2 or 3 days and probably going to continue on at 2 or 3 days a week. And did a little bit more work on the scripts. I've been kind of held up by not making much progress on the documentation, so we'll try to get that done this coming week. And I guess that's about it. Back to you, Dave.
Well, fine business. And then next on the list, we have David McGaw, N1HAC. Go ahead.
Oh, hello, everyone. I've been working towards getting our hardware out to Baffin Island. Hopefully that makes it before winter. Just discovered an interesting problem, which may be something we need to address on Tangerine as well. Dynamic range. Turns out that I think where they want to site us is right next to a 1,000 watt AM station and a 6,000 watt non-directional beacon, which is right in our desired band, because we're trying to pick up AKR in the 500 to 1,500 kilohertz. It's like, oh crap, now what do we do? But we'll see what we can do. It should need to be sited farther away than that. At Sonderstrom, Kangalusawak, we were 1.5 miles away from an NDB, and it was a lower power one at that. And I had to notch like crazy to get that out of it. But you know, any of these research instruments that get put out in the field, you know, in the RF spectrum, you got to be aware of these things. We try to null it as best we can, but you know, when you're sitting right next to the antenna, what can you do? Yeah, we're probably going to end up sending a USRP up there for the initial tests. We were looking at the RSP Pro or Duo. Apparently the software is not ready for prime time on that one for doing 2-channel. So we were hoping we could get out cheap, but we won't. And then, as I said last time, very much looking forward to having Tangerine available. So it'll be much more programmable and whatnot. And I can't remember how quickly we think we might get 4 channels, but ultimately that's what we'd like to see. And I've been working a little bit with the magnetometer. The one thing I found, and Dave, you can tell me what's going on. I haven't had a chance to ask you, is when I have it just running straight without doing log files, it stops at UTC midnight. Is that normal, or is there another version of software that would keep running?
Without log files? No, but there may be. Did you download from the GitHub?
Yeah.
Yeah. You might drop back to an earlier, you know, a slightly earlier revision, because there's some things I'm vaguely aware about in the master that are or even in 0.9, whatever the last one was, that I haven't had time to address. In fact, it will it does strange. I know it does something strange if you're not doing log files. And I haven't had time to look into it.
Okay.
Actually, I actually saw it. I've seen it. You know, segfault.
Yeah, that's what it's doing. Is
is that what it's doing? But
yeah.
It does it at midnight. That's what
at
it's
midnight.
Up to.
Yeah, so that's when you otherwise would be changing files.
Very curious. Yeah,
anyway,
I do.
Thought I'd bring that up.
Thank
quickly.
you.
We can talk more later, but that I wanted to ask.
Mm-hmm.
Okay, so I think that's it for me.
Okay,
Back to that.
let's see. Next on the list would be Elizabeth Hernandez. Go ahead, Elizabeth.
Hello, everyone. I don't have any new updates this week, so I'll just be listening to everyone's updates.
Well, Elizabeth, it sounds like you dodged the bullet on the hurricane.
We did, yes. Thank God. We had to evacuate, so, you know, that made us waste some time there, but better safe than sorry. So
yes. Well, I'm glad you had good luck.
Yeah, thank you.
Okay, next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just copying the mail, getting up to date on what's going on, and that's it for now. Back to you, Dave.
Okay. And let's see. Next on the list, we have Michael, AA8K.
Greetings. Is my audio on?
Yes.
Oh, good. I've been preoccupied. We had a side note. We had a repeater, VHF repeater, go down that covers the south half of the county, and it just died. unfortunately, it's at the top of a power plant. And if you're aware of what has happened at power plants, is the security has just gone crazy, and now it's a pandemic. So we got special dispensation to get an employee to go in there and retrieve the equipment, and we brought it here. Yeah, I can show you some. Show you the. Here's the duplexer, and then here's the repeater itself. It's Kenwood TKR 750. By the way, this is what I'm looking at. They said they had a large lightning strike on one of the 1,000-foot stacks, and it took out a lot of equipment. So I was prepared to open and find charcoal, but actually what I found is what I'm quite sure is a manufacturing defect that just happened to fail after 8 years. So you can make an assumption, but it'll often be incorrect.
Yes.
But I did repair it, and we're doing a shakedown on it, and we might be able to get access again with their blessing.
Well, very good.
So I've been busy.
Okay.
Back to Dave.
Okay. Next on the list would be Tom, I guess.
That's me here.
Well,
Yarnish?
Tom, either one. Tom Yarnish, go ahead.
All right, Yarish, no N there.
Okay.
Okay. We're in North Bay of San Francisco, and the fires have been overwhelming us for the last 3 weeks. The air here is better than it has been, but as the fires are being brought under control locally, you have this huge heat wave. And now there's a high wind warning posted tomorrow morning, and they've elevated the fire danger even more.
Right.
It began about a month ago when we had a lightning storm here that took out 2 transformers on my property, lost water, everything else. I had a lot of wire in the air, and the lightning struck at about 4:30 in the morning. By then it was too late to do anything. Caught us completely unprepared. And ever since then, I've had all the antennas tore off my equipment, and I'm gradually finding out what works, doesn't work. I can't report any damage to my equipment here, but it did kill one of our well pumps. So it took us a couple of days to have that repaired. Other than that, I'm working on portable Kiwi SDR and for field work out, and finding optimum noise figures around the property here, following in the footsteps of Glenn Elmore and 6GN and a few others here locally who've made some innovations with the Kiwi stuff. Usually we're running BeagleBoard AIs now to serve the Kiwi, and networking all that stuff either through Wi-Fi or hopefully Bluetooth once we can get all the ports to work. And it's been a project, but done some amazing thing. And I'll refer you to Glenn. He's done some amazing noise studies, and they may or may not be posted yet, but he's very accessible. And I'm following his footsteps, eating the crumbs as they fall. And that's about all I have to show now. I'm just fabricating new power supplies and stuff, battery supplies and regulators, and trying to learn as much as I can about the installation of the BeagleBoard's AI, and we'll take it from there. I have also bought another Kiwi. There was Seed Studios advertised them for $200 a few weeks ago, so I promptly jumped on that deal. So I have 3 Kiwis operating here, and we'll put them all in 8 receiver modes. And possibly with the AI, I can go to 16 on one. Rebuilding my antenna fields. That's about it at the moment. Looking forward to the Taper conference in a few days, and hope to see some of you there. Glenn and I think it's Glenn and Rob, AI6VN, and Gwyn Griffiths, G3ZIL, are presenting a paper there at Taper, and looking forward to that. So I think it'll be a very interesting couple of days. And right now it's 98 degrees outside. Turn off all the equipment in the shack because otherwise it gets too hot here. And maybe in a few hours I'll go outside and have another glass of wine. That's about it.
Very good. So next on the list is Tom McDermott. Go ahead.
Oh, good evening, Dave, everybody. Not too much. I did get a pull request for a GNU radio driver for Hermes. And I always try to test those things before actually merging it. This case, it was an extremely simple little text change to a YAML file. And of course, that resulted in all kinds of memory management errors. And so it was all week spent tracking down, and I think it turns out it's a build problem in the scripts for GNU radio. So after getting it resolved, I ended up putting in an issue into the GNU radio tracker. So it's amazing how extremely small things can cause what appear to be totally unrelated problems. So back to the group.
Fine business. So I think we've talked to everybody. I don't see anybody that we haven't talked to yet. So I guess we're open for general discussion.
Scotty, did you get your presentation to fit into 5 minutes?
Well, first time I did it, first recording was 9.5 minutes. So I chopped a bunch of slides out and I got it down to 5.5. That's as far as I went.
Oh, that's pretty good.
Oh,
only four recording time, 4 times doing it to get it down that low.
With 30 slides, right?
No. I cut it way down. I think I have 6 slides. So it's a record low number for that talk. But
yeah, I did it in one take, but then fixed it with the Caden Live.
So what did you do? Did you take some ums and ahs out or something?
Yeah, there was about 30 seconds of fiddling around trying to find something on the computer keyboard, and things like that got all cut out. So it looked like it was decent when it was done, but it wasn't before it went into the editor.
Well, it's Alt-R to start and stop the recording. But what they don't tell you is if you don't have the focus on Zoom, Alt-R doesn't work. And then if you don't have the focus on the PowerPoint, then the forward and back keys don't work. So you got to make sure and go over and get your cursor over the right piece of the code. And since I have 3 monitors, I kind of have to give it the hairy eyeball, off to the side. I keep looking at the camera while you're trying to get the cursor over to stop the recording when you're done. Otherwise, it looks like you're fiddling around, like the Wizard of Oz behind the curtain, trying to shut things off.
Yeah.
And I didn't do any editing, so I just recorded it raw.
And I ended up using Open Broadcast Studio, OBS, to capture it, and then Caden to edit it.
That's a great way to capture audio or screen grabs.
Yeah, because you can do picture-in-picture, and you can do all kinds of things with OBS.
So you didn't do Zoom to do the recording?
No, I did it all in OBS.
Okay, because I did the Zoom, and there's an option in the video settings that you can put your video up in the corner of the display when you're recording, and I turned that on, and it seemed to work. So
yeah, I was able to toggle between full video camera, full slides, and picture-in-picture, and so that's a nice feature of OBS.
Yeah. And then you can do editing with it too, right?
Yeah, I saved it as an MP4 and then opened that in Caden Live and clipped out most of the boo-boos. There's still one giant boo-boo left in there, but ran out of time.
Yeah.
So have you seen John Ackerman's?
No, I haven't seen his video. He showed me his slides, but he didn't show me the video. But actually, I didn't see how the block diagram that I sent him came out. So be interesting to see how that worked.
Yeah, I think his paper and his presentation, I think, are both really excellent.
So does he stayed to about 15 minutes, right? So the aggregate together, we're about 25.
I don't know what he stayed to. I know he was going to do a separate 20-minute or 25-minute on. Just
Oh
his
yeah, that
paper.
one.
Yeah.
But the one that they're going to combine with, I guess he was going to do 10 minutes on the actual clock module versus the 25 minutes on his 40-page paper on all those clock modules that he evaluated, which is going to be an awesome talk, I think.
Yes.
Yeah, yeah. So I didn't see how his condensed one came out. I guess we'll find out on Friday.
Yeah. Yeah, and also I've
Awesome.
been continuing on getting parts ordered for the magnetometer, and I think we pretty much determined. I'm trying to get my courage up to talk to the CAD guy to ask him to put one more part on the board. I haven't got brave enough to weather the storm that will be forthcoming as soon as I ask him to do that. But I've been looking at the CAD drawings to see if I can go in and I can say, hey Dave, put the part here, and then here's the routing channel, and it actually works. Then he's not as upset as if I try to put some part on that there's no space for, that he can't route to, and that he has to rearrange everything. So, but
Scotty?
I can't really find a place for the part on the top side, and I've already told him no parts on the bottom. So we'll see. I may have to beg him to take a look at it.
Scotty?
Anyway, yeah, go ahead.
Oh, I just wanted to ask, you didn't consider using the 3-volt regulator on the remote that Jules has been recommending so strongly?
No, you can't do that, because if you use 3 volts on the remote, then you use 3 volts on the local, and if you power the devices on 3 volts, the transceiver part works fine.
Oh,
But
that's right.
they're only rated for VDD. The inputs are only rated up to VDD, and the Raspberry Pi is 3.3. So you would actually be overdriving the inputs, which would be not. It probably would work, but I'm not a probably kind of guy. I'd rather not exceed the maximum ratings of the parts. So that's why we really need to stick to 3 volts, 3.3 volts instead of 3. However, what I did do, because of his suggestion, is I went down the line and I found an incredibly low dropout LDO at the current that we're drawing. I barely even believe this myself. It's 6 millivolts of dropout voltage at 10 milliamps, which is more than what we're drawing. I think that's actually at 25 milliamps. So
that's nice.
We should be able to run. It gives us lots of margin. I did the calculations and I came up with something like 3,500 feet. 350 feet of cable that we can run if we use the standard 24 gauge or 28 gauge. What's standard Cat 5? Is that 28?
Must be 28.
Yeah, standard Cat 5 was 24.
Okay, so I did the calculation with 24 gauge and 1 power wire and 2 ground wires, and I came up with about 350 feet. And on the board, if you choose not to use the interrupt that the D-ready line coming out of the part, you can add a single resistor and you can double up the 5-volt lines again, and that'll give you well in excess. It's over 500 feet of cable, just from the drops anyway. Now, whether it'll actually signal that far, I haven't really addressed that, because our requirement is really only 100 feet, so, and we meet that easily. But with hams, they're gonna tack on as many feet as they can get away with and try it.
Scotty, what is your concern about having 3 volts on one end and 3.3 on the other?
Because if you try to drive the chips with 3.3 and power them off of 3.0, then you exceed the maximum rating of the inputs, because they're only rated up to VDD. Now,
well, but the thing is that the local is completely separate from the remote.
But it's the same board. If you wanted to make two different boards, it would work fine.
Well, at least the thing is that the local board shouldn't have a regulator on it anyway.
No,
It
that's
should be
not true.
running off the local 3.3.
No, I do not. I run off of 5 volts only.
Yeah, that's what's different about
Yeah,
your
that's
way of
the
doing it and the
problem.
way that I've worked on it all
But you
along.
could also assemble it with a 3.3 regulator and assemble the remote one with a 3.0 regulator.
You could, then you have two
And the
different,
signaling over the cable is all 5 volt.
but the signaling is already all 5 volts. And if you do it this way, you have enough margin to run 350 feet of cable. So
Yeah,
it's engineered and it works.
okay. The other
Okay.
thing I was gonna suggest is you have a way of separating the 5 volt source that's going down the cable, so you can put something a little bit higher onto it if you wanted to run a high
Yeah, you could do that by taking the inductor off
right.
if you want to do that.
Yeah, somebody could hack it and do that.
Yeah. So I mean, it's possible. Or the fuse, one or the other.
Right.
Fuse is bigger, so it's easier.
Yep.
But yeah, so yeah, I thought of doing the 3 volts. It's a good idea because it gives you an extra 0.3 of a volt margin, but it's, and likely it would work fine because 0.3 of a volt is not even a diode drop. So, but the protection diodes on the part probably would be no problem. But when I read the data sheet and it says VDD plus 0, I'm going to stick with VDD plus 0. I'm not going to overdrive it by 0.3. So we'd have to make some serious changes to make that work. And
it'll be interesting to see how that comes out because at least in Jules's tests, there was a difference in performance using 3.0 volts.
Oh, really?
Yes.
So the readings are different between when you ran it on 3.0 versus 3.3?
Oh.
Or is it a noise thing?
Because the data sheet says it'll run down to 2.7. The part will function down to 2.7.
The magnetometer?
Yes.
Okay, and there's also the MCP9808.
Yeah, and that will run
but
down to 2.7, I believe, also. In fact, it'll run down to 2.0 maybe. The problem, I think, is it's not so much the voltage that you run it at as long as you're within the range. It's that you don't want to be having it fluctuating while you're measuring. And that would be not good because then I don't know what the part would do if your VCC is some kind of
well, yeah, I've worried about that too in other contexts, but
so Dave, when you do the reading of on the part, is the acquisition of the data that occurs over like 1 second, and then you read the data, so it's not actually acquiring during the time that you're transferring the data. Is that correct?
No, well, actually, it's just a few milliseconds. It acquires the data. I only ask for it once a second.
Okay, but
and so a lot of times it's just sitting there.
So it's not many readings averaged together then over the second.
The ASIC on the magnetometer module does do multiple readings, and that's one of the tunable parameters that we've worked with. But no, we aren't really averaging. I guess we could, but that's not what we've been doing. You know, to like doing it every 1/10 of a second, for instance, and just averaging. We haven't been doing that. We've just been reading it once a second. Because
you tell the part how much that you're going to do it once a second, so it does. It's the ASIC does this algorithm that it has internally.
No, I don't. No. I actually issue the request for data once a second. You know, I watch for D ready to go. Whatever it does, you know, not the line, but the software equivalent, which happens in. Yeah, I don't remember. Jules actually timed some of these things, but it all happens very fast, and then I believe it sits there doing more or less nothing for about 80% of the time.
I was just wondering because the time that we draw the most current is the time that we actually read from the remote device, because that's when the driver on the other end is actually powering the cable. And it'd be good if we could avoid actually acquiring magneto data during that time that we're driving the cable, because that would be the time that the 3 volts would droop if it's going to droop. I don't think it will. I did add a whole bunch of more capacitance, and much to the annoyance of my CAD guy, because big capacitors are big. So they
well, that was another of Jose's serious recommendations was that there be more capacitance in on the.
Yeah. So I had 22 microfarad, and what I did was I said, okay, he recommended like 220 or 330. Well, 330 microfarad capacitor in that size, the part cost goes from 30 cents to $2.30.
Yeah.
And so I said, okay, well, I don't like that. So how about what we do is we go to 22 microfarad, and then we put 2 of them on there. And so now there's 222 microfarads, and they're about 35 cents a piece. But if we have to, we could put a $2 cap on there and go to a few hundred microfarad if we need to. I don't think we will, but
I don't think he really, I'm not aware that he really recommended that. He had 2 different values. One was for a ceramic and one was for a tantalum. And I thought they were like 22 and 67 or so. I didn't quite understand why they were so different, but I believe I bought the ceramics, and
well, I think he wanted to get a low ESR. So
yeah,
but the ceramics generally are they're lower ESR these days. And, those are the ones I'm using. Is I don't like Wi-Fi V's. I like X7Rs or some better dielectric. So
yeah, that's the only thing I've used ever.
The one thing you have to be aware of with the ceramics is because they have such a low ESR, they can actually resonate. And I've had problems with high value ceramics on a circuit board and creating noise rather than
removing
bypassing
well, we talked a little bit about this because we have some resistance in series with the capacitors. So this will help us to hopefully not get that problem. And like I said, I stuck with 22 microfarad. That's really not too overly big compared to like 330.
Yeah. The one recommendation is don't put a whole bunch of them on. Put, like normal practice, put 1 on and then bypass with smaller ones elsewhere.
And we do that. We have 22 and then we have a 0.1. So a couple 0.1s, I think, actually.
Yeah.
So
that should be fine.
So, but the main point is that we want to be able to provide the bulk capacitance for when the chip fires up that driver. And because a very small amount of time, but it's a significant amount of current. So, and again, that's why it'd be nice if we could like not be acquiring data while we're transferring data. I mean, I've actually worked on boards where you deliberately do that because you know that transferring the data is noisy. So you stop acquiring, transfer the data, and then you turn the acquisition back on. So you don't do it at the same time. Because the acquisition costs almost no current. I mean, the magnetometer draws like a half of a milliamp or something. It's very low. But the drivers at peak current is about 80 milliamps, but it's for this really narrow little length of time. So you want to keep them happy with some capacitance right next to the chip.
Now I might have put a delay in the software. Maybe that's why he asked me to. I know I put a delay in there at one point at Jules's request that didn't make any difference as far as I could see, but he thought it was a good idea, and it's a small delay and it's just in the C code, so it's like I can't say exactly why that is. I haven't looked at it in a few weeks, unfortunately.
Well, the idea is that to mitigate the problem of sharing the I2C bus, we decided to actually run an I/O pin over to the enable pin of the transceiver. So that if we shouldn't need to do this, but if we need to do this, we can turn off the transceiver and talk locally, and then turn the transceiver on and talk remotely. So if we have to, if we have some kind of conflict or speed issue or something with the remote part, then we can disable it. Now, I'm not planning to, I plan to depopulate that resistor. We're going to put a 0 ohm resistor in to connect it. It's going to be there just in case we need it, but we're not going to plan on using it because I don't like connecting up Raspberry Pi IOs to enable pins without software to drive it. We might be getting ourselves into a big problem. So I'm going to leave it disconnected for the prototypes, but we'll have the capability to fix it without adding wires if it turns out that it's a problem. I think we're going to be okay because what John says is he uses the I2C to initialize the synthesizers on his board, which is done one time at power up, and then he doesn't mess with it after that. And all we have to do is make sure synthesizer chips pick different I2C addresses, and he doesn't run any faster than our maximum speed, and we should be able to share it. By definition, it says we should be able to. So, of course, the best way is to get the development boards of the two parts and hook them together and see if they actually work, but he hasn't picked the synthesizer chip yet. So kind of hard to do that until he picks the chip. But I don't want to wait any longer. Once you guys have determined that the magnetometer chip actually works and produces meaningful data, we need to move ahead and get some out in the field.
Well, is the only outstanding thing that casts any doubt on that question is the lack of correlation with Jenny Jump, as far as I'm aware.
Is it just one outlier then?
Only one outlier, and we have many, many other. Most of our work has been elsewhere, and it's all, I believe, been good. Jenny Jump is the question. One thing I wondered, I was just wondering the other day was, when was the Jenny Jump? I know it's been asked before, but when was it last serviced? And how much has declination changed in that period of time? The field vectors may be distinctly different than when it was last calibrated. I don't know,
Well,
but
I can say a little bit about declination because right now,
I was hoping you would, yeah.
where I am, we just passed declination 0. And when I was a Boy Scout many years ago, it was declination 5.
And that's degrees, right?
Degrees.
Yeah, and
so it's floating across right now, and quite dynamically, more than the USGS ever expected when they printed the maps.
Yeah, and I don't know if that could have, if something like that could have any impact. But just a question. It's just one more question.
And I don't know what it is for you, Scotty, but in Seattle, it's 22 degrees.
Yeah, so we would be much higher than you.
Yeah, something like that.
Something in between, I would guess.
I don't see why the change in declination would affect the magnetometer readings, but I certainly also don't know when the last time the Jenny Jump magnetometer has been serviced. So that's a very good question.
Well, in the last 10 years, the magnetic pole has moved north considerably.
Yes, no, I agree with that. What I'm saying is I don't know why that would have anything to do with the Jenny Jump magnetometer not, giving the correct reading.
That would be just equivalent to rotating the magnetometer off axis, right?
Yeah, but the magnetometer is doing X, Y, Z, so.
Yeah, I mean, you should still have the Jenny Jump magnetometer and the Magneto Pi Hat or David Witten's magnetometer reading the same measurements.
Yep.
But
Unless it's mounted on
it,
top of
but,
a
but
rock
it is.
iron ore in it.
I do think it's a very valid question to ask. Is a Jenny Jump magnetometer, actually measuring what we think it's measuring?
Well, especially when it's the only one that's out.
Right. Yes.
Well,
So
we are actively trying to collaborate with the Colorado people with a magnetometer here in Missouri, but they have been delayed from May. They still haven't stated a time at which they're going to install their magnetometer. We may even get to installing ours first. So.
Yeah. Install something somewhere.
It's a race.
Yes.
So Dave, you have a Dave KB0S. You have a Max 10 development board, right? The one we bought from.
Yes.
Okay, and Dan, do you have one of those too?
I do not.
Okay. Because I think that's probably the one we ought to use to develop the software loader on. Because I was thinking we could use the IQ2 because Dan has one of those and you have one of those and I have one of those, but that's a Cyclone 5.
Yes.
If you use the Max 10, then it becomes a much easier port just moving the pins around.
Yes.
So you want to buy one of those, Dan?
Yeah, I can do that.
They're about $200, or at least when I bought mine.
Yeah. And it's cheaper to buy it from DigiKey than it is directly from Terrasic.
Yeah.
And I'll get together with you and find out what the part number is for it so I buy the right one.
Okay. I mean, iQuad can buy one for you, like we bought the other one. Got to get some benefit,
That's right. So just as a point of reference, 20 years ago, Phoenix was about east 8 degrees. Right now, it's east 12 degrees.
Yes. It's amazing how fast it's been changing. And so in my classes, I teach foresters to always go to the declination site and check it so that they know what their current declination is. Where used to, people just referred to the map, but the maps are all out of date.
So
just as soon as they print them, basically.
So Dan, how many years was that from 8 to 12 degrees?
It was about 20 years.
20 years, okay.
Yeah.
It's moving about, what was it, about 35 miles, or is it 35 kilometers a year, kind of to the north and west, I believe.
It used to be over Hudson Bay, and it's moving out into the Arctic Ocean.
It's those Russians.
That's right.
Oh, and then I told Dave about what day was that? Friday or Thursday? We had a magnetomic spark, essentially the way it was explained in the thing that I read was that the tail on the signal from the sun was out of phase with the polarity of the earth. So over Finland, they had an unusual aurora, which looks like needles.
Wow, that was strange looking.
Very strange looking. And they called it a discontinuity in the magnetic field. The A part of the magnetic field.
So would that be something we could have measured if we had all these magnetometers out?
I don't know. Nathaniel, do you know?
I'd have to look at the paper more carefully. So I'm not sure. I'd have to look at that.
Yeah. This is it happened in 03. This is an event that happened in 03.
It didn't just happen.
It happened Thursday.
Oh, but then
And
it
it
had,
was
the last
there
happening
was chatter about it on space weather, and there were some NOAA comments about it as well.
So do they know how often this occurs?
Well, the last one they recorded was 03.
So 17 years ago, huh? Well,
Yep.
we'll be able to beat that time. I hope.
Pancake.
So you want to see this new SDR that you have to go
Yeah.
and buy?
I think I have several. It didn't look that different than some others that I've seen.
It only had Windows software, it sounded like.
Yeah.
Is that right?
It runs HDSDR and another SDR software that I wasn't familiar with. You want to let me share, Nathaniel?
Sure.
Yeah, definitely. Go ahead.
So that's the board there. Comes in a nice case like yay. And let's see, one of them was, let's see, HDSDR. It comes with an EXTIO for HDSDR. It's actually a clone of a version that an Italian guy's been working on, and it's on his blog. Let's see.
IK1, well, you moved it too fast.
Sorry, did I move?
XPV. That's not.
Yeah, Oscars. BBRF103. It's a clone of that, and this one is supposed to have a 2208 ADC, which is when you could go on. I bought mine on eBay, which nets about $200 because the fashions charge you tax. But if you go on what is it, Alibaba, you can get it for $180 and free shipping and no tax. I don't think they charge tax there. But it's what it's got is it's hard to see on here, but I believe, I can't tell which chips are which, but they actually have an RTL SDR chip on there, and they have a 2208. So it's direct sampling below 32 megahertz, and it is the RTL dongle above 32 megahertz. So you can get a full 32 megahertz of bandwidth on the HF, in the HF spectrum, and you can get, I believe, up to 8 megahertz of bandwidth in the VHF, UHF, up to 1.8 gigahertz. And what they did on this one is they put a 20 dB preamp on the front end, which the earlier one did not have. And what else did he do? There's 3 attenuators you can switch in, and it uses looks like it uses the Cypress USB 3 chip. So there's no FPGA on board. So that would mean there'd be a limited amount of processing you can do of the IQ data, of the raw data, before you ship it out. So I'm guessing they just ship raw data out, and they don't do any quadrature mixing. Like you'd have to have an FPGA or something to do mixing it at that speed. I mean, you're getting 16-bit samples at I think they run at 61 or 62 megahertz, so you get about 16 nanoseconds per sample. And again, it's supposedly open source, but I have not been able to find a schematic of it yet. So
Scotty, do you have yours yet?
I don't. I just ordered it today, and it's donkey post from Hong Kong, so it'll be 3 weeks or 4 weeks before I get it. Actually, they said the vendor I ordered it from, one of the guys on here said he got his in 7 or 8 days. So because it was shipped DHL, so cross your fingers, maybe it'll be shipped that way. It's not what it says on the website, but we'll see how it comes out. So I just wanted to get it and play with it and see what you can. But like I said, I think if it really is just taking raw RF samples and putting them out on USB 3, we can do that with the data engine. And we have 2 channels. So now we probably can't put both channels out on the USB port because we don't have that kind of bandwidth. But we could put 1 full channel out, or we could strip it down to 8 bits of data and send both channels, or we could do the quadrature mixing and we could send I and Q data, and it would be, you know, mathematical I and Q instead of some kind of timed I and Q, which would be not as good, not as accurate. So you end up like on SSB, you couldn't get really good opposite sideband rejection if you do like, unless you do a mathematical mixer. Anyway, it looked pretty intriguing for 190 bucks or 200 bucks. So we'll try it out and see what it does. It looks like you probably get it on the air pretty quick if it has an EXTIO and runs HDSDR. It should be pretty simple. Although I did read some issues with the USB, is that it's like you unplug the USB and plug it back in. You have to power off the board. So they have some kind of software issue, I guess, with the Cypress part that it doesn't like being disconnected and reconnected. But just minor details, maybe something they can fix with future firmware updates. And let's see, I did find a block diagram. See, AliExpress is the other place. I call it Alibaba, but it's really AliExpress is where you get, because isn't Alibaba like the 40 Thieves, right?
That's where it comes from, though, I believe.
Yeah.
Yes.
If I search for GitHub, the problem is that there is a piece of stereo equipment, a vintage stereo gear that is called an RX380, RX888, and so I keep getting hits for the.
It's a JVC
yeah
receiver or something.
Anyway, there is a GitHub for this guy here, and it does show a block diagram, but it's very simplistic. And let's see, all I'm seeing is sellers now. I'm not seeing the link to the GitHub, which is what I was hoping to find. Anyway, there's maybe some better pictures of it. And the amazing thing is, it runs off of the USB 3 power, which has got to be just right at the hairy edge, because that 2208 draws about a watt just by itself. And I'm looking for the link, but I don't see it. So there was actually a link to a schematic that was partially cut off, but it was not to this board. It was to Oscar's version.
Well, there's two links to Oscar in that document
Right here?
there. Yeah. There's one there and one below. Is this where you were?
This, let's see. No, that's not it. And if you go down here, yeah, because this is all about his BBRF 103, which is essentially the same hardware architecture, except this one has a preamp in it. Yeah, here's where I was found the links right here. I think it is right here, maybe. No, it's just more pictures. Oh, here's the GitHub right here. So if you go here, you can see the schematics are really not complete, but if you go here, here's the block diagram. And it's a 2208, not a 2217. I haven't looked up the difference. I suspect that the 2217 is just a slower version, but I haven't looked it up. But you see, it uses the Cypress FX3 to do the USB, but there's no other compute engine on here. So any processing of the data has got to be done inside this chip here. So you're limited to whatever the horsepower that guy has. And it looks like since they limited 0 to 30 megahertz, that they're clocking at 60 some megahertz, not 122.88 like we are.
Yeah, I guess you're at the mercy of whatever oscillator they stick in there.
Yeah, and the part of the problem is if it really is like this, then this synthesizer is what's driving the encode clock. This is not going to turn out very well compared to the way we're doing it, where we have the clock module driving that, so we have much better control over it.
This is the other one, but I did notice that they had a GPS module on the board you were showing us.
Oh, they did?
Yeah, if you look,
I don't think so. I think that.
What was it? It was a metal case, and it said GPS on the outside of it.
Says GP something.
This one right here?
I saw that.
Yeah, what does that say?
It does say GPS, doesn't it?
Yeah. Now, is it really a GPS or is it something else?
Yeah.
No, I think it's got to be something else because there's no GPS antenna connector.
What is this guy right here?
Oh.
Yeah, there it is.
Oh, maybe there is.
Yeah, this is why I was really searching in earnest for the schematic, because I really wanted to see what they do. I mean, I don't believe any of the block diagrams, you know. Just show me the schematic of the board you actually made, then we'll see what's really on there. But that would be pretty tremendous if it was included a GPS for that price.
Yep.
Because the ADC alone is about 60 bucks. And the GPS has got to be at least another $30 if it's a timing GPS, wouldn't you think? I mean, it can't be a $5 El Cheapo GPS if they're going to use it for timing.
Yeah.
Of course, maybe they aren't using it for timing. Maybe, who knows?
Yeah, they could. But I mean, why else would it be there?
I don't know. That's what I would use it for, you know. So you can tell who stole your board, where it is. You can go get it back. Like tracking your cell phone, right? No.
Or your Tesla car.
Presumably, if that's really what it is, they've got a GPS DO on there.
Yeah, yeah. In which case, wow, you know, that's pretty. Anyway, we'll see when it gets here. Two separate antenna inputs. One of these goes into the RTL chip. The other one goes into the ADC. This is the preamp, I'm sure. Though no, actually, this is the switch for the attenuators, which are right here, and then that's the preamp. This is the ADC here, I bet, because it's got a heatsink on it.
What's the other heat sink next to it?
Probably the Cypress part.
Oh, okay.
That hooks to the USB. And then this GPS would probably come in on a serial port to the Cypress part.
Yeah.
And I don't know how they'd have to get a 1 PPS input somehow, and
I will mention we're at our time, and I'm going to see most of you several times this week.
Yeah, I hope everyone will be at DCC starting on Friday morning at dark 30 Pacific, and normal time for Easterners.
Mm-hmm. I'm planning on it. I also spoke to Steve, and he said that he'd be able to use some ARDC funding to pay for my students to go to the DCC this year.
Yes.
Yes.
That's some of that's left over from the last year's grant.
Mm-hmm. So I sent him the list of emails for those students. When should they expect to get an email for that?
Anytime now, so here's what has happened is that the Tapper opened up the sign-up sheet before we were actually linked to Zoom.
Okay.
So a bunch of people signed up and they didn't get any notifications because they weren't linked to Zoom, because Zoom has to actually send out the invites with their special password and all that. So now George is actually manually entering those pre-registered guys, the early bird guys that got in ahead of time, after, Dave, I don't know if you know the date, but after a certain date, it was all automatic. So you
Yes.
sign up and you get the email. So I'm sure what Steve's going to do is just enter those people's names in, and they'll get an email from Zoom.
Okay.
So should be in the next day or two.
That's great, because I told my students that they're required to watch at least 2 presentations and write about it.
Oh, okay.
Very good.
Well, hey,
I made them a deal because Jonathan, who's on here with me, he's in one of my classes. We decided like we should just cancel class on Friday so that we can, make sure we can attend the DCC. So I said, that's a great idea, but I'm teaching a digital signal processing class and an undergraduate research class. So I'm like, well, that's perfect. We'll just make the students attend 1 hour's worth of DCC presentations. They write about it, and then that counts for them attending the class.
So during your class time, which presentations are on?
I think so the first class is at 1 p.m. Eastern. So.
Okay, so that would be before. That would be the personal space weather station stuff, I think, because.
Yeah. But I told them they could pick what they wanted to watch. So I said they have a full 2 days. I said they didn't have to, I said they just have to pick 2 1.5-hour presentations that they want to go watch, and they can write it.
Well, so that means if they don't get the invite, they're going to be chomping at the bit and asking you where it is because it's course credit. Right?
Yes, which is why I'm asking about it.
Well,
if they don't hear by, let's see, today's Monday. I would say if they don't hear by Wednesday, let me know so I can go kick Steve and make sure he sends out the invites. So
okay, I might send him a quick reminder tomorrow or touch base with him.
It's on his list, but he's got so many things to do.
I know.
Yeah.
But it's really important for those guys.
Yeah, right. Because I asked him today if anyone got an invitation, and no one said they got.
Well, and no one said they did because actually, Dave.
I know. I got an invitation.
Yeah, I think John said or George said they've all been sent out except for the early birds.
So maybe I'll just send George and Steve an email tomorrow and just touch base with them.
And send them the list and say, did these guys get a notification? And that way they'll be able to verify. And in fact, hold on just a second.
I did my invitation and I did register.
You did, you got it. But you registered also, right?
Yeah.
Is Steve asking the people to register, or are they just going to be automatically registered by him?
Well, I registered with the Zoom link.
Okay, so you went on the Tapper page and registered that way?
No, I only registered with the link that I got from George, because he sent me that earlier a couple hours ago.
Yeah, I got a link from George too. But Jonathan and I are both presenting, so.
Yes.
Right. Yeah, actually, I think maybe that is true. That's all the panelists that he made. He said everyone got their emails, but the attendees, not necessarily. So that would be the question that I would have. Is I would suggest that they go to the web page and sign up. Except, of course, it's going to want to charge them $30 if they're not a Tapper member, and so we've got to figure out a way around that if they're being paid for by the grant. So, so Steve might have to just register them himself.
Yeah, I'll just send Steve an email tomorrow morning.
Yeah.
And I guess
see you guys on. Well, I see Scotty like Wednesday and Thursday.
Thursday and Friday.
And then Friday and Saturday. But I'll see the rest of you on Friday and Saturday.
That sounds great.
Good night,
You're
all.
going to be around tomorrow?
Oh, Dave, is that you?
Yeah.
Yeah? You want to talk tomorrow?
I don't know if you have time.
Yep, I think I have time.
Okay.
I'll send you an invite.
Sure.
Yeah.
73.
We'll see you guys later in the week.
73,
Dan, are you going to be around for a minute?
Who?
Dan.
Oh, go ahead.
You're going to be around for